Welcome to David Alexander Maths Tuition. This is chapter 2F on combining transformations. Okay, so here are the common transformations that we're likely to encounter, and these are the ones that you really need to stay on top of. So first of all, y equals the f of x plus a. So this is just going to be moving the graph horizontally to the left or to the right. If it's plus a, that means we are going to move it to the left. So it's a bit counterintuitive. If it's negative a, we're going to be moving it to the right. Basically, we're going to be moving it with the vector negative a 0. So the y coordinates are not moving, but the x coordinates are. So as I say, if it's plus a, then that means this is going to be a minus a here, so that's going to be moving it to the left. And if this is minus a, then this will become minus a, in other words plus a, so moving it to the right. Now if it's f of x plus a with the plus a outside the brackets, this is nice and easy. That means the graph is just moving up or down, and that is just going to be moving with the vector 0, a, so the x coordinates won't change, but the y ones will. We're just going to be adding a to all the y coordinates. If y equals the f of negative x, so here the transformation is inside the brackets, so that is going to affect the x coordinates. So if all the x coordinates are going to be flipping their sign, what this is a reflection in the y-axis. And similarly, but oppositely, if here the negative sign is outside the brackets, so if it's outside the brackets, it's going to affect the y. So if we're making all the, or if we're changing the signs of all the y coordinates, then that means that this is therefore going to be a reflection in the x-axis. Okay, so these last two are probably the y equals f of the a of x is can be quite a confusing one. So we just need to remember that this is a horizontal stretch. Now it's the scale factor that causes the issue. The scale factor is 1 over a. So if it's f of let's say 3x, then the scale factor is 1/3, so it's all just going to be squished, sort of compressed. So if we're looking at, let's say, sine waves, that means because it's going to be compressed, you're going to be getting 3 sine waves for the price of 1, basically. Now, if y equals a f of x, this is quite easy. This is just a vertical stretch, and the scale factor is literally a. So if it was 3 f of x, then all we're doing is whatever the graph is, we're just stretching it, making it 3 times as tall, 3 times, well, just making it 3 times as tall. Nice and easy. So I'd say the ones to watch out for are definitely the y equals the f of ax. That can be a little bit confusing, and sometimes people get the f of x plus a wrong. Remember, plus a means going to the left, and minus a would mean going to the right. Okay, so in this example here, we know that the curve with equation y equals the f of x passes through the origin. So it's going through 0, 0, and it's going through point A, which is 5, 7. So how will these points be relocated if instead of it being y equals f of x, the transformation is y equals 5 f of x minus 3? Okay, so in this first example, the 5, that is going to be a vertical stretch, and the minus 3, that is going to be just shifting the whole graph down by 3. So both of these transformations are going to be affecting the y coordinates. So first of all, well, if I know it's only going to be affecting the y coordinates, then the x's will remain as they are. So it will remain as a 0 and a 5. So what we're doing is we are multiplying all the y numbers by 5, and then we're subtracting 3. So 0 multiplied by 5 is 0, subtract 3, negative 3. 7 multiplied by 5 is 35, and take away 3 is 32. So 5, 32. Okay, now the next one, y is the f of x plus 3 plus 2. So we're going to do the transformation inside the brackets first. Well, the one inside the brackets affects the x, whereas the one outside the brackets affects the y. So actually it doesn't really matter which way around we do it, but let's do the one inside the brackets first. So here we need to be subtracting 3 from the y coordinate, from the x coordinates. So if I subtract 3 from 0, that is negative 3, and if I subtract 3 from 5, that will give me 2. and for the transformation that is occurring outside the brackets, so this is just going to be shifting all the y's up by 2, so literally adding 2 to all the y values, so 0 will become 2 and 7 will become a 9. What about y is a half of the f of x take away 2? Okay, so I'm going to do the one inside the brackets first. So this is going to affect the x coordinates, and we do the opposite of what it says. So we're going to be adding 2 to the x's. So 0 will become a 2 and 5 will become a 7. And this half, this will affect the y. So it's a vertical stretch with scale factor 1/2. So what we're doing is we're multiplying all the y coordinates by a half. In other words, we're dividing them all by 2. So 0 divided by 2 is 0, and half of 7 is, we'll just call that 7 over 2, and we're done there. Okay, let's look at this example. So the function f is defined by x take 3 squared take 7, and we want to first of all draw a sketch of it. Well, hopefully we can do a sketch of x squared showing a quadratic curve going through the origin of 0, 0. So this is x squared. X take away 3 squared is going to be the x squared graph shifted 3 units to the right. So therefore the turning point will be now at 3, 0. And if it's x minus 3 squared minus 7, this is just affecting the y coordinates. So we just subtract 7 from the 0. So the turning point is going to be 3, negative 7. So the only problem is if I now do a little sketch showing this turning point of 3, negative 7, I might get my y-intercept wrong. So let me work out what my y-intercept is to inform me on how to actually do a slightly more accurate sketch. Now remember, the y-intercept is when x is 0. So I'm going to substitute 0 into this equation. So 0 take away 3 is negative 3. Negative 3 squared is 9. 9 take away 7 is 2. So the y-intercept is 0, 2. So that helps us know that actually the y-intercept is positive, so it needs to be above the origin and not below it. And what are the x-intercepts? Well, the x-intercepts is when y is 0. So if y equals x minus 3 squared minus 7, well, that is the function, then let's make this equal 0. So 0 equals x minus 3 squared take away 7. Add 7, so 7 is x minus 3 squared, so therefore x minus 3 is going to be the plus or minus the square root of 7, and then we're going to add 3, so therefore x is 3 plus or minus root 7. So one coordinate is going to be 3 plus root 7, 0, and the other x-intercept is 3 minus root 7, 0. Okay, so we've got our turning point, we've got our y-intercept, and we have our two x-intercepts. So now all we just need to do is a quadratic curve with these points labelled. Okay, so now we are transforming the turning point. Now we know that the turning point is 3, negative 7. So if it's transformed with 3f of x minus 2, so these x minus 2 means we need to be adding 2 to the x coordinate, so 3 will become 5, and this is a vertical stretch with scale factor 3, so the graph is going to be 3 times taller, so that means we're just going to be tripling all the y coordinates, so negative 7 will become negative 21. Okay, let's look at this supplementary question. So we know first of all that the turning point is 3, negative 7, and the transformation is the f of 3x, so that is going to be a horizontal stretch with a scale factor of 1 over 3, so well 1/3. So all we need to do is multiply the x values by 1/3. Well, 1/3 of 3 is 1, so the turning point will now be 1, negative 7. And finally, if the transformation is the modulus of the f of x, so remember that the turning point was 3, negative 7, so the modulus of the function makes any y value that is negative positive, so we're just making this negative 7, positive 7, so the turning point will now be 3, positive 7.